we will discuss about internal combustion engine and gas turbine theory. So, as I said that I will discuss about the internal combustion engine, different aspects of internal combustion engine, applications, different parts, their operational principle, and gas turbine theory will be taught by my colleague Dr. Vinayak Kulkarni. So, this is the week-wise course plan, the course content that I am going to discuss in different weeks, rather lecture-wise. So, today I will discuss about the external and internal combustion engines, engine components, and SI and CI engine. So, internal combustion engine is very important because when we talk about internal combustion engine, that means the combustion is taking place internally. There is external combustion engine, that is steam engine, that is what we know that earlier days people used to run train by using steam engine. But internal combustion engine, that we need to know what are the different parts of the internal combustion engine and what are the operational principle, what are the different types of internal combustion engine, and of course I will discuss in detail about the combustion and different types of fuel used for internal combustion engine, all those things. Now, very important is that for this subject, particularly for internal combustion engine, prerequisite is that students should know, rather students should have knowledge about heat transfer and thermodynamics. So, today I will discuss from the basic things, that if we talk about heat engine, that is what we have studied in thermodynamics. So, we know that if a heat engine, that is an engine working between two temperature reservoir, one is higher temperature reservoir, another is lower temperature thermal reservoir, TL or TC, whatever it is, I will say TC, TH and TC, and this is engine is drawing heat QH and this is rejecting heat QC, and if it runs and if we get W net amount of work from the engine, this is heat engine, that is the engine working between two temperature thermal reservoir, one is the hot TH, another is a cold TC, and it is extracting heat from higher temperature thermal reservoir QH and producing some amount of work W net, and it also rejecting heat QC to the low temperature thermal reservoir TC. Now, we know that the efficiency of the engine, eta thermal efficiency will be equal to W net by Q in. W net by Q in, here Q in is equal to QH. So, now W net is equal to what? QH minus QC divided by QH. So, I can write this is 1 minus QC by QH. So, this is the thermal efficiency of the heat engine. If it is, I can again write that if it under reversible condition. So, this eta thermal under reversible condition can be written TC by TH. This is under reversible condition. So, this is 1 minus TC by TH under reversible conditions, but this is only for the Carnot engine, not for other engines. Now, question is, from this, if we would like to mimic system, suppose we have a system and we have a weight, let us say W, and like a piston, and if I supply heat to the system, let us say from a temperature reservoir TH, and if we have a gas inside the, or whatever it is, I mean either gas or any working fluid is there inside the cylinder, the piston cylinder arrangement, then it will expand and it will try to lift. Now, and let us say this is 1, and again if I like to bring back the piston or the weight in its the original position, then I have to extract heat from this, and in that case it will take heat TC. Suppose again I am connecting the system to a thermal reservoir where it is rejecting heat, and in that case if I can extract heat, and then I will be able to bring down the weight piston in the original position. But it is not operating in a cycle, right? It is not operating in a cycle with any single reservoir, because heat must be, so whenever I am raising the piston, of course, then piston will move. In that case, it is not operating with a cycle, with a single reservoir. So we need to bring back the piston in its original position, and for that we need to extract heat, to bring the piston in the cylinder. Now to produce a work, so what we do? So whenever it is connecting with one, it is not a cycle because it is operating with a single reservoir. So we need to bring down the piston in its original position. For that we need to have the connection 2. Now to produce a work, connection 1 is made. So to produce a work, connection 1 is made, because to produce a work, connection 1 is made, right, to bring down the piston in its original position. So to bring down the to bring down the piston, rather weight. So to bring down the piston in its original position, connection 2 is done. Connection 2 is done, already made. And piston and to work in a cycle, so it is basically a cycle. So this is basically a cycle. So I have connection 1, from where I am supplying heat to the system, piston will move off. If I would like to bring back piston in its original position, again I need to connect system through connection 2, and it will reject heat to the TC. And see, if I have kind of reciprocating motion, that piston is moving up, bringing down, moving up, coming down, and if I somehow can convert the reciprocating motion to the rotary one, in that case I can rotate wheel. So this is a cycle. So until and unless we are connecting the system through connection 2, it is not a cycle, because it is working with a single reservoir. So maybe to produce work, connection 1 is made, but again to bring back the piston or to bring back the weight in its original position, we need to make another connection through 2, and in that case it is a cycle. Okay, but again I am telling, in that case again, if I can have a reciprocating motion of the piston, and if I have any connecting rod, crank and connecting rod mechanism, and by which I can convert this reciprocating motion to the rotary one. But I am telling you, this is not a practical possible cycle. So why? So this is, I am writing, this is not a, although cycle, but this is not a practical possible cycle. Why? That I will discuss. Because construction of huge reservoir, depending upon the requirement of the load, we need to construct huge reservoir. So construction of huge reservoir, source sink, not possible. So this is not a practical possible cycle. Why? Because depending upon the load, we need to construct huge reservoir, that is not possible. Again we need to construct huge source and huge sink. So this is not a practical possible cycle, but we can borrow the concept, and if we from that heat engine, and if I somehow construct a engine from where it will be working in a cycle, and from where I will have a reciprocating motion of the piston, and if I can convert that reciprocating motion into the rotary one, then I can rotate wheel. This is all about the concept, and that is what I am getting from heat engine. Now question is, I will discuss in detail that although it is a cycle, but I can't call it a thermodynamic cycle. Why? That I will discuss in the context of operation of different engines in our subsequent lectures. Okay, so external combustion engine, that is what I told, that in that case combustion takes place externally, and from there we can somehow have again reciprocating motion, and we can convert that into the rotary one, and it will allow to have a rotary motion, so that I can run any either train or whatever it is. But internal combustion engine, where combustion takes place internally, so there will be some constructional difference between external combustion engine and internal combustion engine, that I will discuss. But before I go to discuss about those, let us first briefly discuss about the types of engine. If I talk about internal combustion engine, then what are the types of engine? So broad classification of internal combustion engine. So broad classification of internal combustion engine. So, this is broad classification of internal combustion engine. I can classify engine into different categories. Number 1, I can classify into, first one is number of strokes, right. Again, number of stroke, it can be subclassified into two categories, 4-stroke engine and 2-stroke engine, right. 4-stroke engine means we have 2 revolution of the crank per cycle, per one cycle. So, I am writing here, there will be, for 4-stroke engine we will have 2 revolution of the crank per one cycle, and for 2-stroke engine we will have 1 revolution of the crank per one cycle. So, this is all about number of strokes. So, I can classify engine based on the number of stroke, and for that we may have 4-stroke engine, 2-stroke engine. We will discuss about what is a 4-stroke and what is a 2-stroke engine. 4-stroke engine will have a 2 revolution of the crank per one cycle. In case of a 2-stroke engine, we will have only 1 revolution of the crank per one cycle. So, because of 2 revolution of the crank per one cycle, we will discuss what are the different strokes, and probably how many ideal strokes are there, how many power strokes are there, that we will discuss, and I will discuss what are the benefits of having 4 strokes instead of 2 stroke in a internal combustion engine. Second is, that can be, again engine can be classified based on the types of combustion. Types of combustion, it is again spark ignition engine, spark ignition, that is SI engine, and compression ignition, and this is compression ignition engine, CI. So, compression ignition and spark ignition engine. Spark ignition engine is used, I am writing here very a few points. Spark plug, an external agent which is used to initiate combustion. Spark plug is used for SI engine. Number 2, fuel injector is used for CI engine. Fuel plus air, not only air, fuel plus air is introduced in SI engine through a special device which is known as carburetor, through a device which is known as carburetor, is very important part of the SI engine, and it is with that of, so SI engine are working with that of Otto cycle, but in case of a CI engine only air is introduced, and air is introduced in CI engine, no carburetor, for CI engine no spark plug, we use the high pressure and temperature of the fuel itself to initiate the combustion. And these engines, when you talk about CI engine, that is we need to map the thermodynamic processes in a we need to map the processes which is occurring in a CI engine in a thermodynamic plane, and through which we compare, in which we need to map, say if it is 4-stroke engine, different stroke, and at each and every strokes what are the thermodynamic state, that is pressure, temperature in a thermodynamic plane, and that is compared with that of the diesel cycle, So, these are the few fundamental points that we should be remembered, I mean we should remember rather. For SI engine, spark plug an external agent which is used to initiate the combustion, because we need to initiate combustion through this spark plug. We cannot use the high pressure and temperature of the fuel itself. On the other hand, fuel injector is used for the compression ignition engine, that is CI engine. In case of SI engine, because air fuel itself cannot can be ignited. So, when we talk about combustion, fuel itself cannot take part in the combustion, we need to supply air. So, in case of a SI engine, fuel plus air is introduced into the cylinder through a special device which is known as carburetor. And again I am telling that whenever an engine is operating, so thermodynamic state will change at each and every stroke, whatever it is, if it is 4-stroke engine or 2-stroke engine. So, we need to map the thermodynamic processes, we need to know the thermodynamic state at the end of each stroke. And for SI engine, those are compared with that of the Otto cycle. In case of a CI engine, only air is introduced, fuel is introduced through fuel injector separately, and the thermodynamic states are mapped in a plane, rather thermodynamic plane, and which is compared with that of the diesel cycle. Okay. So, now we have talked about CI engine and SI engine. So, I will now briefly discuss about that fundamental difference between spark ignition and compression ignition engine. So, fundamental difference between SI and CI engines. So, based on the types of combustion, we can classify engine spark ignition, CI ignition engine. We have discussed about that for spark ignition engine we should have spark plug, because we cannot use the high pressure temperature of the fuel itself to initiate combustion, and we need to supply air plus fuel through a special device carburetor. But in case of a CI engine, only air is introduced through air intake line, while fuel is introduced through fuel injector, and we use the high pressure temperature of the fuel itself for initiating combustion, and because of what we need not to have spark plug external agent. But there are, although so in a CI engine we should not have spark plug, we should not have carburetor, but now I will discuss about what are the fundamental differences between SI and CI engines. While SI and CI engines have much in common, so I am writing that while SI and CI engines have much in common features, there are certain fundamental difference that cause their operation to vary considerably, that cause their operation to vary considerably. So, while SI and CI engine have much in common, because so far we have discussed about a few features, that means in CI engine we should have a fuel injector, in SI engine we should have carburetor and spark plug, but still there are certain fundamental differences that cause their operation to vary considerably. So, now we will list down what are the differences if I can tabulate those differences. So, I am writing first one is basic cycle, based on basic cycle. So, number 1 basic cycle, if I talk about the SI engines in general is based on the Otto cycle, that is what we have discussed. So, SI engines in general is based on the Otto cycle, right. So, this is basic cycle I am comparing, number 1, while CI engine in general is based on diesel cycle, right. So, this is very important. So, if we talk about basic cycle, there is a difference that SI engine in general based on the Otto cycle, while CI engine in general is based on the diesel cycle. Number 2 is very important, that is the introduction of fuel, that is what we have discussed, introduction of fuel. How? In most CI engine, the fuel and air mixture is introduced into the combustion chamber as a gaseous mixture. So, I am writing again that in most SI engine, fuel and air are introduced into the combustion chamber as a gaseous mixture. As a gaseous mixture, a carburetor is necessary to provide mixture, and throttle valve controls the quantity of mixture introduced. So, I am writing a carburetor, that I already told that a special device, a carburetor is necessary to provide the mixture, and throttle valve controls the quantity of mixture introduced. Right. So, in most of the SI engine, fuel and air are introduced into the combustion chamber as a gaseous mixture, and for that a special device which is known as carburetor, which is used to supply or provide the mixture, rather I can say the stoichiometric mixture, that I will discuss about what is stoichiometric mixture, and a throttle valve which controls the quantity of mixture. But in case of a CI engine, fuel is introduced directly, but in case of a CI engine, fuel is introduced. In case of a CI engine, fuel is introduced directly into the combustion chamber, directly into the combustion chamber, and air is introduced through air manifold, and air is introduced through air manifold or intake manifold, air manifold. So, the air manifold is there through which air is introduced separately, while fuel is sprayed, rather introduced directly into the combustion chamber. Number 3, which is again important, that is ignition. So, basic cycle that we have discussed, that SI engine in general based on the Otto cycle, CI engine in general is based on the diesel cycle. Basically, we would like to map the thermodynamic, we would like to map the thermodynamic state, the variation of pressure and temperature during every stroke in a thermodynamic plane, and that is compared with Otto cycle for SI engine, and in case of a CI engine we use diesel cycle to map those. Now, based on ignition, the SI engine require an ignition system, because that is what I told, that for SI engine we require an external agent which is known as spark plug, because without spark plug you cannot ignite the fuel. So, to initiate combustion in the engine cylinder we should have sparking system. So, SI engine requires an ignition system. SI engine requires an ignition system culminating in spark plug with the combustion chamber to initiate combustion. System, and which is done through carburetor, a special device. SI engine requires an ignition system which is normally done through spark plug, and with the spark plug within the combustion chamber that is placed. I will discuss while I will draw the schematic of an internal combustion engine. Spark plug with the combustion chamber, essentially to initiate combustion. So, this is done to initiate combustion. So, SI engine requires an ignition system that I am telling you. Rather, I told you that in case of a CI engine, we normally use the high pressure temperature at the end of the compression stroke to ignite the fuel. I mean, without having an external agent, without having spark plug, we can initiate combustion in case of a CI engine, but in case of a SI engine, we cannot start combustion without having spark plug. So, that is we need an external agent which will ignite the system through a spark plug, and that is provided at the top of the combustion chamber, and this is done essentially to initiate combustion. But in case of a CI engine, so the CI engines utilize condition of high pressure and temperature, condition of high pressure and temperature produced by the compression of the air, produced by the compression of air in the cylinder, because we take during intake stroke, if we talk about 4-stroke engine, so I will discuss. So, during intake stroke we introduced air in the cylinder, during compression stroke we compressed the air, and at the end of the compression stroke when air is having high pressure and temperature, then we ignite, we spray fuel. So, we utilize the high pressure temperature produced by the compression of air in the combustion chamber, in the cylinder rather, in the combustion chamber or in the cylinder, I mean to initiate combustion, of course when fuel is injected, So, in a CI engine what we do, what is done normally, air is compressed at the end, towards the end of the compression stroke, whenever air is having high pressure and temperature, fuel is introduced or fuel is injected, and the engine itself utilizes the high pressure and temperature of the air during the end of the compression stroke to initiate combustion, of course when fuel is injected. So, this is next is very important, compression ratio. So, I will discuss about again what is the compression ratio. So, this is for the present range of compression ratio for SI engine. For SI engine, compression ratio CR, which present day, even today's present day, range compression ratio varies from 5 to 10.5, but in case of a CI engine, this compression ratio for CI engine, this compression ratio varies from 12 to 20. So, compression ratio is high for the CI engine. We will discuss again this issue while we will be discussing about the operational principle of the engines, whether it is SI and CI. So, SI engine is, for SI engine compression ratio varies from 5 to 10.5, but for CI engine it varies from 12 to 20. And number 5, this is very obvious because this is called weight. compression ratio, weight is directly related to the compression ratio. So, since compression ratio for SI engine is less, so weight compared to CI engine, SI engine is having lesser weight. It is obvious because compression ratio is less. Again I am telling compression ratio, roughly I am telling compression ratio high means cylinder which needs to withstand high pressure. So, when we talk about cylinder, so of course pressure inside the cylinder. So, this acts like a pressure vessel. So, compression ratio high means the cylinder which needs to withstand high pressure. So, if we think about that the cylinder itself is just like a pressure vessel. So, to withstand that high pressure, engine cylinder wall should be much more, will be thicker as compared to that of the SI engine. Since the engine wall should be thicker essentially to withstand high pressure, it should have a higher weight. So, that is why for CI engines are normally having higher weight. So, this is the thing that is very important, that so these 5 are the fundamental differences. So, what again I am repeating, although there have many more more features which are common for both the engines, but still there are some fundamental differences, and fundamental differences are based on let us say basic cycle, as I have discussed that basic cycle SI engine based on the Otto cycle and CI engine is in general based on the diesel cycle. I mean we compare the thermodynamic states during each and every stroke, rather at the end of each and every stroke in a thermodynamic plane, and that is what is this we talk about cycle. Although we are calling it a Otto cycle, diesel cycle, but those cycles are not thermodynamic cycle, that again I will discuss, because although we are mapping thermodynamic states rather states in a thermodynamic plane, but those are not thermodynamic cycle, rather we will call it mechanical cycle. We will discuss. Introduction of fuel, that is very important, because in most of the SI engine fuel and air are introduced in the cylinder, because I mean to be precise, fuel and air should be in a gaseous mixture. They are introduced as a gaseous mixture, and I mean whenever we are supplying fuel air mixture to the cylinder, we should, rather the engine should take the stoichiometric air fuel ratio essentially to have very efficient combustion. I mean if we supply more air or less air, then either combustion will be, mixture will be too lean or too rich. In that case combustion should not be efficient. So, essentially to have efficient combustion we should supply stoichiometric air fuel ratio, and that is done through a special arrangement which is known as carburetor, because carburetor allows to supply gaseous stoichiometric air fuel ratio, and it allow the fuel air to be mixed in a form of that is in a more homogeneous form. And we have a throttle valve that controls the quantity of mixture that is introduced, but in case of a CI engine fuel is introduced directly into the engine cylinder, while air is taken through air manifold. Ignition again is very important, that is what, because to initiate combustion in a SI engine we need to have an external agent, that is spark plug. So, spark plug is provided which is placed at the top of the cylinder. So, at the end of the compression stroke we need to initiate the spark plug, which will allow the ignition that essentially to allow to create a spark which will allow the combustion to start, I mean initiate the combustion. But in case of a CI engine, that is very important that air is compressed, and whenever air is compressed towards the end of the compression stroke, air will have a pressure temperature. The condition of that state will allow combustion to initiate when fuel is injected without having any external agent. 4 is SI engine compression ratio. Compression ratio is something that I told you that compression ratio indicates the pressure that is that we need to build during the end of the compression stroke. So, in case of a SI engine, since we are having external agent for that is spark plug to initiate combustion, so we do not require that the pressure and temperature of the air fuel mixture to be that high. I mean, and for that compression ratio is generally low, and since compression ratio is generally low, that means engine does not require to withstand the high pressure, and for that weight will be less, because engine wall of the engine cylinder is need not to be very thick. In case of a CI engine, because we are utilizing the condition of high pressure and temperature to initiate combustion without having an external agent, so of course we need to have high pressure and temperature at the end of the compression stroke, since we need to withstand that, since we need to develop that high pressure, cylinder has to withstand that pressure, and for that if we think about that cylinder is acting like a pressure vessel. So if cylinder would like to, cylinder is withstanding that pressure, so of course the wall of the cylinder has to be thicker, and for that CI engines are normally having higher weight. So with this I stop my discussion today, and I will continue my discussion in the next class, where I will discuss about the schematic diagram of an SI engine, and then we will discuss about different strokes, rather 4-stroke and 2-stroke engine. And when you talk about 4-stroke engine, what are the different strokes, and as I said you that in a 4-stroke engine we should have 2 revolution in a per of the crank in per 1 cycle, while for 2-stroke engine we should have 1 revolution of the crank per 1 cycle. So of course we will have certain advantage and disadvantages, rather advantages and disadvantages when we talk about 4-stroke and 2-stroke engines, and we will discuss in details. And of course we will discuss about the schematic of SI engine. So maybe we need not to draw the schematic of CI engine again, because SI engine and CI engines are schematically they are defined that in a CI engine we should not have spark plug, we should not have carburetor, rather we should have fuel injected to supply fuel into the engine cylinder directly, and air will take through the air manifold. So those issues we will discuss in the next class. Thank you very much.